Let's bypass the fluff and dive right in, because honestly, way too many students lose easy marks on the semi-quantitative Benedicts test. But by the end of this explainer, you're going to know exactly how to secure those high-level method marks. We're talking about a painful, totally avoidable mistake that can literally cost you a whole grade boundary if you aren't paying attention. I'm going to show you exactly what Cambridge examiners are hunting for, and more importantly, how to systematically build a top-end answer every single time.
So, why do students consistently fail to interpret complex data and graphs in this test? We're starting right away with a massive error that costs students heavily, and that is bungling data interpretation and formatting on this specific practical exam. You might know the science perfectly, right? But when you hit the practical investigation design and those tricky data analysis questions, ordinary revision just kind of fails. Why? Because this topic doesn't just test what you know, it tests how you handle information and how you design experiments. Memorizing facts? That's really only one piece of the puzzle.
Just look at this quote. Candidates consistently confuse key terminology, always define terms before using them in extended responses. That is straight from the Cambridge Principal Examiner reports. They are practically begging you to set up your theoretical architecture before you start analyzing anything. The whole conceptual framework rests heavily on precise definitions. Jumping straight into your answer without establishing them, well, that's a guaranteed way to drop easy points. Okay, so let's start by defining our core concept perfectly. A semi-quantitative Benedicts test is a procedure that estimates the approximate concentration of reducing sugars by observing a spectrum of color changes rather than yielding an exact numerical value. Semi-quantitative simply means we're estimating concentration through that color spectrum. We're not producing a perfectly precise number. A fully quantitative test gives you a specific numerical value, kind of like a digital reading. But this test, it's semi-quantitative. We are making accurate observations based on sequential instructions to find an approximate concentration. The absolute crucial point here is making sure your examiner knows that you understand this distinction right out of the gate.
Moving on to our next section, the crime scene. Top examiner warnings.
3. That is the exact number of massive, reoccurring pitfalls you must be aware of to survive this test. When you're sweating under exam timing pressure, it is so incredibly easy to fall into traps that the principal examiners see thousands of times a year. Let's look at the specific data about student mistakes so you don't end up repeating them. These 3 errors are the exact reason why highly prepared students walk out of the Biology 9700 exam feeling great, only to suffer a massive confidence shock on results day. Here they are. You lose marks when you confuse cause and effect, when you forget to check your units and terminology, and when your answers are not specific to the context given. Think about it. If you just memorize a textbook definition but completely fail to deconstruct the question and extract relevant data from the stimulus materials they provide, you're going to get a 0 for that section. You absolutely have to integrate your knowledge with the specific syllabus context given to you in that exact prompt. No generic answers allowed. No. A huge part of using the correct terminology is picking the right analytical framework. Notice how this perfectly aligns with what the examiners expect. You need t-tests for comparing means between 2 sets of data. You use chi-squared for analyzing categorical data. And correlation tests? Those are for finding relationships between variables. Choosing the wrong statistical test immediately shows the examiner that you just don't understand the experimental variables you're working with. All right, let's look at our next section. The secret weapon. The perfect answer framework. So we know the mistakes, but what is the exact phrase examiners hunt for? How do we systematically secure those higher order marks and build an answer that commands full points? In just a moment, I'm going to show you the exact examiner clue that changes your answer completely. But first, you need the framework that makes that clue super obvious. Because if you don't have a standardized, systematic sequence for processing the question, that phrase will slip right past you, and you'll leave vital points on the table. Here is your secret weapon, laid out in 4 steps. Concept, evidence and data, scientific reasoning, and examiner wording. This is the method mark strategy. Examiners award marks for your process. You must start with the concept, extract the evidence and data from the provided tables or graphs, apply your scientific reasoning, and finish with the exact examiner wording. If you follow this sequential execution, identifying key elements, executing your analysis with crystal clear working, and presenting it in the appropriate format, you're practically forcing the examiner to give you top band marks. Time for some practice. Section: Live Fire Exercise. Fixing a flawed answer. Let's put this framework to the test with a quick interactive challenge. Imagine a student writes this exactly on their exam. The solution turned red, so it has more sugar. This causes a change.
Pause for a second and think about the analytical levels we just went over. Can you spot exactly which of the 3 examiner warnings this student totally ignored? Where does this fall short? Let's break it down. First, it completely fails to use specific terminology. Saying more sugar is a super vague concept. The examiner needs to see higher concentration of reducing sugar. Second, the student completely misses the contextual data by providing 0 color spectrum comparison. They failed the practical observation requirement entirely. And lastly, they horribly confuse the causal relationship by just stating this causes a change. It lacks all scientific reasoning and evidence-based justification. A total disaster for your grade. Let's compare that flawed answer to a top band one. A top band answer applies our framework perfectly. It looks like this. The brick red precipitate indicates a high concentration of reducing sugar, supported by data showing. See the difference? This uses precise descriptive, analytical, and evaluative levels. The brick red precipitate, that's a clear, accurate observation. Indicates a high concentration of reducing sugar. Boom, there's our exact terminology and concept. Supported by data showing, and here's where you'd integrate your specific table or graph extraction. It flows logically, and it hits every single method mark. And as this evaluation strategy quote reminds us, comparative analysis requires identifying similarities and differences using comparative connectives. Crucially, when you're forming that scientific reasoning step, you have to use those comparative connectives. It's never enough to just say 2 things are different. You must explicitly identify the similarities and the differences using words like whereas, in contrast to, or similarly. That proves to the examiner you are actively evaluating the evidence, not just reciting it from memory. Let's wrap this up. Section Mission Debrief. Essential exam takeaways. Let's bring this all together so you can walk into your Biology 9700 exam with a repeatable, high-mark strategy. We've gone through the procedural framework, the core principles, and the examiner insights. So here is your ultimate mental checklist for exam day. 1. Always define your key terms to establish your conceptual framework. 2. Use the 4-step sequence strictly for every extended response. 3. Select the right analytical framework like a t-test or chi-squared to match your variables. And 4. Compare thoroughly using both similarities and differences with proper connectives. Do this, and you will capture those method marks that everyone else leaves behind. But wait, what happens if you apply this perfect framework to the wrong command word? You now have the ultimate framework to craft a top band answer. But guys, it's completely useless if you misinterpret the hidden instructions the examiner is actually giving you. Imagine writing a brilliant, scientifically flawed evaluation, only to realize the examiner just asked you to describe. Because here is the absolute truth. Command words decide the mark band. The exact hidden cause of losing easy marks, even when you know the science perfectly, is misreading the Cambridge command words. They dictate your entire mark band. Command word awareness is the ultimate filter. It honestly doesn't matter how well you can calculate or design a practical investigation. If you are answering the wrong specific prompt, you are instantly kicked out of the top band. To learn exactly how to decode these command words and lock in your grade, make sure to subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. But before you go, I want you to think about the last past paper you completed. Did you actually answer the exact question the examiner asked, or did you just answer the one you wished they asked? Think about it. See you in the next explainer.